Thanks, Rob. Hello, everyone. Hi, HashiTalk Secure. Hope you're all doing well. Today, we're going to go through an overview of a minimum secure pipeline. It is a little bit of a joke of a minimum viable product, but what I determined was that MVP often doesn't mean secure. And so what I wanted to talk about today was when you are deploying, whether it be infrastructure or application, what is the minimum secure pipeline that you need to deploy it? And I get requested this topic a lot. I figured I should compile an overview. And mostly the reason why this has become more important in recent years is that we've realized that our pipelines are not very secure at times. And there have been a number of public incidents where we've either exposed something in public repositories, pipelines themselves have printed things out, plugins for pipeline frameworks or CI frameworks have exposed something or have been exploited. And so today we have to think more carefully about how we build our pipelines. In the past, it was just enough to say for MVP, we need some deployment pipeline to get from development to production. Now it's not really a sufficient statement. We have to say it is a secure pipeline as well as an effective pipeline to go from development to production. So what does that look like? Well, I wanted to build a picture, an overview of what a minimum secure pipeline should look like. If you have any questions about that, you can always reach out to me. This is an abbreviated version of a much longer discussion with very deep technical details that we can go into for each section. So if you do have questions, you can always reach out to me. Okay, so our goal is to secure better and remediate faster. It's not to say that everything is secure and not to say that we're going to be perfect every time. But the idea behind a minimum secure pipeline is that we're going to better secure how our applications go to production and also remediate any problems that happen very quickly. Pipelines scale quickly as well, right? You can imagine that once you start with one deployment pipeline, you can copy paste it and scale it to many different applications. That's also from a developer experience standpoint, why you would bootstrap a lot of pipelines as well. So pipelines scale very quickly across an organization. And so it works to your benefit to learn how to remediate those quickly should something happen. Securing a CI/CD pipeline involves, I would say, 5 separate components: access control, secrets, runners, dependencies, configurations. We're going to go through all of them today very quickly. And again, we're not going to go into too many of the technical details, but I'll try to provide some concrete examples when possible. Let's start with access control. Access control is how do you access other systems? And in security, there's this idea of the principle of least privilege, and that's limiting a service's access rights to the minimum required targets or services that it needs. Least privilege is incredibly difficult. We strive for it every day, and the reality is it's an ever-changing outcome or an ever-changing goal that we're looking for. So it's really difficult to maintain. Pipelines, more than anything, require least privilege because pipelines are all about access. There's literally nothing about a pipeline that doesn't involve access. So if you imagine this sample pipeline, you can say, I'm checking out code. That means you have to access a code repository, meaning you get read access to them. You build your infrastructure, which means you have access to an infrastructure provider, which means you write specific services. You deploy an application, which means you need access to the application platform, and on and on and on and on. Everything about a pipeline requires access. So access control becomes the top component that you have to think about when you're developing a minimum secure pipeline. And least privilege in that mix is incredibly difficult because sometimes you don't know what your pipeline needs access to. It's easy to say, hey, I'm going to grant administrative access to everything so my pipeline can write or create all of these services and resources it needs. But the reality is it probably doesn't. And so trying to limit the amount of access that a pipeline needs can be very difficult. It's also an iterative process. The challenge of least privilege has a few solutions. The first is that you limit access from the pipeline to other targets very early in development. The reason why you do this earlier than later is that it's a lot harder to take away certain privileges or access than it is to grant it. So limit the access early, and that means that you can get into that process and the rhythm of iterating on what access a pipeline needs. The other piece is to limit write access to repositories early in development. It's easy to say that every repository that you need to commit to, you're going to give write access, but most of the time you're only reading from a repository. You don't tend to actually make a commit from a pipeline unless that pipeline is CI or CD related and it involves some kind of cascading changes to other pipelines. You typically don't write to repositories. from a pipeline. So make sure that's read access only, but read access in itself also has some difficulties. We'll talk about that later. The next couple of things that you can do, solutions to fixing or addressing the challenge of least privilege, is to offer self-service and offer templates. Self-service is really important because we want a way for people to gain access and audit how they're gaining access. We don't want to give someone broad access to systems in a pipeline. Again, it's a lot easier to say, I want access to my infrastructure provider, have that self-service capability, and allow someone to build that into their pipeline. If you don't offer self-service for access control, it makes it incredibly difficult to scale and audit who has access to what. And offering templates of secure policies becomes incredibly important. We'll talk about configurations later, but templates for secure policies means that you can write a policy in a very specific manner, and you're able to reproduce that across different groups and different users and different identities. So for example, let's talk about Vault. If you have example Vault policies that describe what secrets that someone should have access to, and you template and you parameterize the path by which some service has access to it, that makes it a lot easier for you to copy those policies, make sure that they're read-only or even update-only if that's the case, and you can scale that across multiple pipelines. The important thing about templates is to have known secure templates, not necessarily the ones that are always the most perfect in security and the most secure ones, but maybe ones that are functional and minimally secure. So offering templates really alleviates that problem. And finally, reviewing access on a regular cadence and auditing pipeline runs becomes part of your day-to-day. Reviewing access on a regular cadence is an important exercise. There are tools that will help you do this, especially in the cloud providers. They're oftentimes going to analyze what access control has been granted, whether or not the role itself has been using these API permissions, and they'll give you an audit report of whether or not you should include or remove certain access policies. So using that mechanism is often a great way to ensure that your pipeline or a role or an account associated with that pipeline has the proper access, and you can remove any API access it does not need. Also, auditing pipeline runs becomes very important, especially if you want to know whether or not someone is adding a stage in a pipeline, potentially printing out passwords and just making it easy for themselves to gain access to other systems by using a service account or other pipeline identity. So auditing those pipeline runs becomes a very interesting challenge. I would say not too many people do dump the output of their pipeline runs into one aggregated place and index, and goes through the process of indexing everything. But it becomes pretty valuable when you're reconstructing who's using the pipeline, what the pipeline is doing, has a stage been injected that it shouldn't be. Okay, secrets. Secrets are not fun. Secrets actually are really fun. Secrets are sensitive information linked to access to a system or service. Pipelines, again, since they're all about access, naturally they have a lot of secrets because they need access. So you need API tokens, usernames, passwords, certificates sometimes. All of these secrets are usually put into a pipeline. And I think it's the biggest question that I get when it comes to CI/CD. Where do the secrets go? How do I get them into my pipeline securely? And it's really easy to accidentally print out something in your pipeline. For example, I've done this a few times already where I'll pass in some password information that I want to set using Terraform for, let's say, my database secret backend connection or something to Vault. And then it gets printed out in plain text. And then I'm like, no. So it's easy in some ways because I could rotate the password, but it'd be nice if I didn't print it out in the first place, right? If I wasn't using Vault and I wasn't using a secrets manager and I wasn't able to audit that I had printed it out and identify which pipelines were using the secret, I would have to do Plan R, which basically means regretting everything, revoking that password or username or token or anything that secret specifically, rotate it, find out where it's been referenced, replace it, and rerun. When you have to do this across 100 pipelines, you're exhausted. You spent a lot of time remediating the problem, and you've not done it that quickly. You've spent 2 days trying to figure out and identify which pipelines are using that secret. So it doesn't scale well. What is the alternative? Well, when you have a bunch of secrets, identify which secrets are being used. And if you look at your pipelines, I generally identify a couple categories of secrets, right? There are secrets involved in testing. Sometimes they involve certificates. There's maybe some user data, and there's usually some encryption keys that are available from a testing standpoint. And then when you think about general access, so this is not necessarily the testing stage, but this is when the pipeline has to deploy something. These involve username, passwords, tokens, and SSH keys. SSH keys are a little bit of a rarity when it comes to pipeline, but sometimes if you have, let's say, code repositories or other access to systems using SSH, this is probably one of those reasons that you have to consider the access again. And then when you have configurations, configurations is more on the infrastructure as code side, but when you're trying to pass in, let's say, a username or a password to a resource or a configuration, those you need to lock down, pipelines will often create them because maybe you're running some infrastructure as code to create it as well. So there's two sets of secrets that you have to think about when a pipeline does it. So to address the challenge of secrets, what are some solutions you can think about? Well, the first is to mask or omit in pipeline output. We say we are going to do this, and we don't always. I think a lot of the CI frameworks now have the ability to detect and mask pipeline secrets. So if you define it, then it will say, okay, I'm going to automatically mask those and redact them in the output. However, if you are using your own CI frameworks or you're using your own custom plugins to extend how a pipeline interacts with other systems, you may not be actually masking or omitting any of those secrets at all. So go through the process of checking whether or not the pipeline output for those plugins or any of the scripts that you're writing does mask those secrets. You know, if you, let's say, use like a bash script in your pipeline and you are printing out all of the commands, it's really easy to accidentally print out a password that you've set as an environment variable and you forget all about it. So certainly mask or omit those. And even better, use a secrets manager like Vault. If you are using something like Vault, it's an easy way for you to retrieve the secret and then store it in the lifetime of the pipeline that you're running. And then afterward, it goes away. So you could, if you wanted to get very sophisticated with it, offer a secret with that pipeline, with the life cycle that only lasts till the end of the pipeline run. So this is maybe more relevant for if you're using Terraform and you want to issue credentials for a cloud provider. Maybe you only limit the access to the lifetime of the pipeline of Terraform running. And then after that pipeline completes, then you revoke those credentials. So the other next thing that you can think about, and this again goes with the secrets manager, issuing new credentials per pipeline run. If you treat secrets immutably, this makes it a lot easier. So if you are going to create a pipeline run, you can link that to an identity and issue new credentials for that. You can also audit your secrets usage. Auditing your secrets usage allows you to link whether or not someone has used that pipeline secret that you've exposed, or someone else is just using that pipeline secret as a way to, let's say, break glass access to production. But auditing the secrets usage is incredibly helpful for understanding whether or not there is something that is being run as part of automation, or it's being a break glass scenario or out of band from automation. Runners. Runners is the third component to a pipeline. And we don't talk about these as much because this tends to be an enterprise use case. But runners are resources that run pipeline stages or tasks. More often than not, we use a managed service. Sometimes we'll use the managed service CI framework and they'll bring the runners to you. You don't manage them yourself. So the result is that you might not need to secure it, but as you scale and you grow, you might decide to dedicate runners to run pipeline stages or tasks. And sometimes these runners are for sort of jump access to other parts of other systems. So there's a lot of interest in building your own runner, but you also have to secure that. There's two ways in which someone can use a CI/CD runner to get access to their systems. Well, someone can access the CI/CD runner directly using SSH to a virtual machine, and then that virtual machine, which is the runner, accesses other infrastructure. The other way someone might think about it is that containers are now a more popular runner for CI frameworks. So if someone accesses a CI/CD runner, they might use SSH, they might use something else, but within the runner itself, what they're able to do is mount the host file system, and the container can now access the host file system. So that means that they can exploit that, access the underlying virtual machine, which the underlying virtual machine can access code or files for other jobs. This is actually quite an interesting pattern and it's got a few steps to it, but it is actually a lot easier to say, okay, I'm going to exploit other containers or other jobs that are running on the same virtual machine, and see if I can get code or file access for the other jobs. So this is what happens when you have, I would say, like a multi-tenant CI framework that is running a lot of jobs at once. And you do want orchestration, you want workload density when it comes to runners. There's a cost efficiency to it, a resource efficiency to it, but there's also a security consequence as well. So how do you secure a runner? Well, most of the time when someone is looking at a runner, it tends to be a human accessing the runner directly. So when you configure your runner, make sure it's an authorized user, and you might consider allowing IP addresses over VPN. Runners, you building your own runners means that you do have the option to secure it over VPN. You could also potentially use Boundary or some kind of privileged access management tool to access that runner. And the runner, when it accesses the other services, whether it be infrastructure provider, a managed service, or secrets manager, should be an authorized account. So you want to make sure that the runner itself has a specific identity assigned to it, and you're assigning that identity, its own unique identity, to each of these services. And the second part of this is a network security requirement, which is allowing IP addresses for the CI framework. Now, the network requirements, which are kind of listed there, like IP address over VPN or IP addresses for that CI framework, are a little bit more difficult to maintain sometimes, just because you may not know what IP addresses the runner is associated with. So if you've got, let's say, a public CI framework and you want to secure your runner that way, you may or may not know what IP addresses the runners is supposed to be running on, and you may not be able to allow those IP addresses. So it may not be fully sufficient, which is why you have two layers, and that's why you have both of them act as compensating controls for each other. So how do we solve the challenge of securing runners? Well, securing runners involves a couple things. Use trusted or verified images. If you are running on a virtual machine or using container runners, make sure you're using trusted or verified images. Try not to use public images, mostly because you don't know what their update cadence is, and you also don't know what is necessarily going into them unless you're scanning for OS vulnerabilities. So that's the second part. When you bring your own runner, you want to make sure that you are using ones that you trust, but also ones that you've done your due diligence on, especially because it's easy to install a package and forget that you've installed it. So make sure that you have an image repository that you're relying on and you're scanning it on a regular basis. As a second portion to this, it's not sufficient anymore to say, I'm just going to use identity or I'm just going to use trusted images. You also want to define a network policy, and you also want to run a general system policy to run as non-root. So both of them will offer you the ability to ensure that your pipeline, should something go wrong with either the image or someone accesses the runner anyway, you have adequate network policy as well as other system controls to prevent someone from exploiting additional parts of the system. So limiting the blast radius and mitigating any impact that someone might have. Finally, using ephemeral secrets and auditing remote access to the runner becomes a really important part of monitoring the system. Ephemeral secrets means that the lifetime of the secret only lasts for, let's say, the lifetime of the job. And this is actually a nice way to ensure that if someone does get access to the runner and they have access to secrets, they have a very limited amount of time by which they can access other systems. So that's helpful with a secrets manager. And then auditing remote access to the runner becomes a little bit trickier. There are some points where auditing remote access isn't something you do for a managed service, a managed CI framework, right? A third party isn't necessarily going to give you all the audit logs for who's accessing the runner. Some do, some don't. But if you have, let's say, Boundary, and you're using Boundary to secure your runners, you can use eventing to audit the remote access to that runner and who's accessing through the runner through a Boundary worker, for example. So being able to audit remote access to runners is a really nice thing to have, especially when you have to go and reconstruct an incident. We're almost there. Dependencies. Dependencies are becoming more popular as a concern because dependencies are all about third-party code that you use for pipeline stages or tasks. We've been talking a lot about supply chain security, right? And so we talk a lot about third-party code that's not third-party dependencies or libraries that you're using in your application, but you actually use a lot more third-party code in pipeline stages or tasks. And the reason why is CI frameworks depend on plugins. If you're using a community CI framework, oftentimes you're using community plugins, and they may or may not be verified. So dependencies become a really important consideration to securing your pipeline. Let's look at this example pipeline. This is an example pipeline that releases my Go binary. And in this example pipeline, I check out some code, I set up Go, and I run Go releaser. What is not in this pipeline is I don't actually know if this action, in this case, it's a plugin for GitHub Actions, but I don't know if this action is verified or not. I'm just using whatever's out there. And then on top of that, I don't know if this action is pointing to a trusted source. I'm also not really sure if this is the correct plugin that I should be using either, right? So Go Releaser is really useful, except I don't actually know if I'm going to Go Releaser and getting it or I'm going somewhere else. So this actually becomes more problematic when you run your own CI frameworks and then you use third-party plugins that you don't otherwise know about. So in the case of, let's say Jenkins, you might have an unverified plugin that you're using. And that unverified plugin, if you haven't looked at the code, you haven't scanned it, might have something like a get files. And a get files method that will replace the project files or metadata, or it can have code that gathers information or code to siphon credentials. It's common enough now to just pull down a set of plugins and say, okay, this functionally gets me to where I need to be. Maybe this plugin references another system automatically for me, but you don't necessarily know what is in said plugin. And you could have some kind of code in there that has that is siphoning information to a third-party system. So what are some solutions to securing dependencies in pipelines? First, scanning for vulnerabilities within the plugins or third-party dependencies that you're using. This can be hard sometimes, and you may not know every single dependency that you're scanning, but it's still great to do the due diligence as much as you can. So if you can check your third-party plugins or dependencies, scan them just like you would do static code analysis on your own application code, that is a great way to ensure that you're not going to introduce something into your systems. Verifying checksums and signatures. This is actually pretty interesting as well. More recently, we've been talking about how do we verify that a third-party body of code is something that is, well, it's actually what we expect it to be and where we're expecting to get it from. Verifying checksums and signatures are an extra step in a pipeline, but now it's becoming more important to do as part of a minimally secure pipeline. We previously never really had to think about this. We just kind of said, okay, well, we know it's from an internal registry or a private registry, so we don't have to think about it. But now we're emphasizing more and more the importance of and the usefulness of open source tooling and third-party tooling, but we also have to make sure that we're downloading it from the right place and it is indeed the correct binary we expect to use. And second to that, use a verified registry. If you want to make it easier, you don't want to have to verify checksums and signatures in your pipeline directly. You might decide to do some initial pre-work to scan and verify those third-party dependencies and put them in a verified registry. There's a friction to this from a development standpoint, right? So you have to get the security verified before they go into the registry. But sometimes there are perhaps really important plugins that across the board you're going to be using across hundreds, if not thousands, of different pipelines. So you might as well put those common plugins into a registry and make sure you pin the versions for them. Finally, configuration. Pipeline as code is the ability to define delivery pipelines through source code. If you're familiar with infrastructure as code, pipeline as code is pretty similar. You're just defining pipelines. Pipeline as code makes it really easy to scale and reproduce different pipelines for different teams. It also has a really nice way of allowing you to template specific steps and use security testing or static analysis to check whether or not those templated steps are what you intend. So for example, I might have a couple of policies that I've written. One is test plugin checkout has fetch depth of 1, and this makes sure that fetch depth of one only fetches the main directory. It doesn't fetch everything. And so that's a policy that I'm going to have on my pipeline as code. I also have another policy that Go uses secure version 1.14, for example. I'm also checking whether or not a plugin release includes a signature. And if it doesn't, then I'm going to fail that as part of my policy. So there are ways that you could apply policy as code to pipelines as code as well. There's no limit to where you can apply it to. I mean, you could say you're going to use a regular unit testing framework, write a set of policies to verify and check YAML or JSON for these pipelines, templates especially, and say, okay, let me double check and make sure all of these stages are correct. Or you can say, I'm going to use OPA or any of the other policy as code frameworks that are out there. The challenge of securing configuration does have a few solutions. So the first is adding immutability to pipeline configuration. Rather than updating pipelines in place, most of the time you do want to try to template and offer pipelines for the 80% of use cases that are out there that are pretty common. So that means deploying an app, maybe running some data science jobs or something. But the point is that you want to treat them by replacing rather than updating in place. So if a new pipeline configuration is going to be created because you have to add a stage like verifying checksums, replace all of the pipeline configurations. Don't really go copy pasting and updating all of those pipelines in place. Finally, offering pipeline templates with secure defaults is a good way to scale secure defaults. If you offer some templates available and pipeline configurations referencing those templates, it's a good way to ensure that you're cascading those secure defaults across all configurations. Testing pipelines as code. We test everything else. We even write tests for pipelines to run, but we don't often test our own pipelines. So at some point, you do have to test your pipelines as code, make sure that it's parsing the information correctly and the stages that you expect to be there are actually in that pipeline template. Finally, securing dependencies that allow arbitrary code or command execution. This is more common as an exploit now, so definitely consider either disallowing it or only allowing it on certain exceptions. Arbitrary code execution can do a lot of interesting things to a runner or to generally a pipeline system. So securing dependencies that do allow that goes a long way to making sure your pipelines are minimally secure. Oh, yes. And finally, audit changes to pipeline configuration. Of course, if you're doing pipeline as code, you're using version control. So maybe this isn't so bad. You have version control, you have commit history to identify who's made changes to pipeline configuration. All right. So in summary, we went through very, very, very quickly the 5 components you need to think about when securing CI/CD pipelines and getting a minimally secure pipeline. Access control is probably the top of the list because your pipelines are all about access. If you start with least privilege early, least privilege access early on allows you to get into the rhythm of adding access. It's much harder to take away access once you've gone to production because you are you live in existence of fear of taking down production. So if you make sure that you limit the access early on, you get into this process of understanding the minimum access that you need in order for the functionality to continue. Secrets are certainly a big part of pipelines. Again, that's the way pipelines access other systems, but also pipelines create secrets. So the more you can secure them in one place, like using a secrets manager, the easier it is to audit and understand how that pipeline is accessing other systems. Runners are more popular as you scale CI frameworks, but when you bring your own runner, you do have to do your due diligence in securing the runner. And some of this might involve the extra work of scanning operating system dependencies, operating system vulnerabilities, keeping them up to date, patching them. As we generally know, patching can sometimes be a hit or miss. So that actually might be something you have to apply. The same process and automation you apply to patching for any other server, you might apply to runners as well. Dependencies are a growing concern. Previously, we didn't really think that much about dependencies. We just said, okay, we're going to pull these dependencies into our pipeline and we're going to use it because we just want to get to production. The reality is dependencies now are a little bit more difficult to secure. We're also depending more and more on third-party ones. So you also want to add some security requirements around your dependencies. And finally, if you haven't done it, certainly take a look at pipelines as code. Now there are ways for different pipelines to pick and choose and modularize different pipeline stages. The better you modularize your pipeline stages, the more likely you are to build some secure defaults into them, and the easier it is to scale these secure defaults across your organization. So with that in mind, if you get all of these in place and you secure all of these components in your pipeline, generally speaking, you're favoring immutability with your CI/CD pipelines at this point. From a security standpoint, it makes it a lot easier to replace the pipeline entirely rather than search and update every pipeline in place. You're naturally limiting the blast radius because you've built the security into your pipeline without necessarily granting massive amount of access from the very beginning. So you're automatically limiting the blast radius. So it kind of saves you time down the line long term. And automating to reduce friction is built in as part of the system as well. So just as much as pipelines automate your path to production, you also probably want to automate the automation that automates your path to production. So automating all of this to reduce friction helps scale your pipelines. It also ensures that they are consistently deployed with the right attributes and secure attributes of that. With that, thank you very much. If you have any questions, feel free to drop them in the chat. And if you have any other ideas or comments on how to expand this further, I definitely welcome them. Reach out to me separately if you'd like.